Two of the most useful device media features are device pixel ratio and resolution. With these, we're able to detect the ratio between the device pixels and the logical pixels, or the physical resolution versus the logical resolution. So in our expression here, we will type device pixel ratio. So the device pixel ratio is the ratio between a device's logical pixels and physical pixels. So for example, the latest iPhone has a device pixel ratio of 2 because the physical resolution on a Retina display is double the logical resolution. It has twice as much pixel density. The physical resolution on the latest iPhone is 640 by 1136 pixels, while the logical resolution, or the actual size of the screen, is half of that. It's 320 by 568. So for example, when developing for a device with a pixel ratio of 1 CSS pixel will be exactly 1 physical pixel on screen. But if the pixel ratio is 2, then 1 CSS pixel will be depicted on screen as 2 physical pixels. It doubles it. So I'll switch over to our simulator and I will switch it to the Retina display so we can see what happens. So when I switch it to the Retina display, it looks a little big, doesn't it? Go ahead and bring up the layout here. Well, our desktop screen isn't physically capable of a high pixel density or a pixel ratio of 2 like the Retina display has. So to compensate for that, the screen size is simply doubled for these testing purposes. Now, if we were on a Retina screen, then our simulator screen size would be the normal 300 by 568 size. So back in our device media query, I'll go ahead and prefix device pixel ratio with min, because like device width and height, we can also prefix this with min or max. So next, we will talk about the resolution media feature, which has much stronger device support, including recent support in WebKit-based browsers. So we'll only need to include the WebKit vendor prefix for device pixel ratio for those older WebKit browsers. Now, all other device browsers will use the resolution media query, which we will add following device pixel ratio. So I'll go ahead and add a comma, followed by screen and a set of parentheses and min resolution. We can also prefix resolution with min or max. The resolution media feature describes the resolution of the device, or pixel density. The display resolution of a screen is the total amount of pixels available. Again, the latest iPhone, for example, has a screen resolution of 320 by 568 pixels. But the pixel density is double that, so it's really 640 by 1136 pixels. Now, pixel density is how many pixels fit in a certain amount of space. It's usually defined as PPI, pixels per inch, or DPI, dots per inch. So whenever you see DPI or PPI, both units describe the same thing. Now, high-resolution displays can really affect the way certain elements appear. Images, for example, can appear detailed and sharp if optimized for higher resolution screens, but if not, they can look blurry or grainy. And we can kind of see that in our Mike the Frog image here. Notice how it's looking blurry and it's lost some of its detail. Well, the image is currently 45 pixels wide by 45 pixels tall, and since the pixel density is twice as much in this Retina display here, it's doubling every pixel in the image. So that's why it's lost a lot of its quality and detail. Well, we can fix this with the min device pixel ratio or the min resolution media features we just created. What we'll do is serve this higher resolution image that's twice as big, it's 90 pixels by 90, So we'll serve this larger image to those devices with a higher pixel ratio or resolution. So back in our CSS file, we will add a min resolution of 192 dpi. Then we will go ahead and select the mic element, where we will add the background image property, and then our new high-res image, which I've named mic 2x, or 2 times. So in our URL here, I will add mic2x.png. So these two media queries are testing for the same feature. As we learned earlier, WebKit min device pixel ratio is only for those older WebKit browsers that don't support min resolution. Now, the comma here in between the two is just like using the word or. So we're telling the browser, if WebKit-based browsers with a device pixel ratio of 2 or higher, or if it's a device with a resolution of 192 dpi or higher, apply the high-res image as the background. Now, how do we come up with this min resolution value? Well, it's actually pretty simple. A device pixel ratio of 1 is always equivalent to 96 dpi. So all we need to do is multiply the device pixel ratio by 96 to get the resolution dpi value. So here, a pixel ratio of 2 times 96 gives us a value of 192 dpi. So let's go ahead and save this and take a look at it in the browser and in the simulator. So when I refresh the browser version, we still see our regular image, which is fine. And I will go over to the simulator and refresh. And when we scroll down, we're seeing the new image, but it's a little too big. It's actually twice as big. But that's fine because that means that our media query is working. We'll just need to adjust the background size to bring it back to 45 by 45 pixels. So back in our media query, right below the background image property, I'll add background size and a value of 45 pixels by 45 pixels. And I will save this. So we'll refresh the simulator. And now we again see the image at 45 by 45 pixels, but its resolution is actually double that because we've made it twice as large. So we've compensated for the higher pixel density, and the image, it's much clearer. We can see all the detail back in our Mike the Frog image. Finally, a good sort of catch-all for high-resolution devices we can use is a minimum device pixel ratio of 1.5 and a min resolution value of 144 dpi. So again, 1.5 times 96 gives us 144 dpi. So these values should take care of the WebKit-based browsers with a device pixel ratio of 1.5 or higher, or any device with a resolution of 144 dpi or higher. Now, if we don't want to do any of this math, we can use a newer resolution unit of dppx, which represents the number of dots per pixels. So I'll simply add a comma here after min resolution and paste in the new dppx of 1.5. Dots per pixels maps perfectly to the ratio value for min device pixels. As we can see, they're both 1.5. So we don't need to do any of the multiplication we'd have to do with DPI. It does lack a lot of browser support, though, at the time of this recording. And since it will always give us the exact same result as using the DPI unit, we can just stick with the DPI value for now. So I'll go ahead and remove this. For up-to-date information on browser support for the dppx unit, you can take a look at developer.mozilla.org. I've posted the link in the teacher notes so you can keep up with browser support.